Okay, baik. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera semua. Okay, bersambung kita kepada topik 3.4 iaitu electromotive force, electric potential and internal resistance. Okay, so selama ni kita belajar about circuit kita. Sebenarnya kita cakap tentang the battery giving a potential difference yang menyebabkan current to flow, kan? But what is actually kita punya potential difference, which is our V. Okay, dan you've learned actually about EMF waktu di sekolah, okay, EMF. So in this chapter kita nak tengok bit in more detail sebenarnya inside the subtopic what does a battery consist of. Okay, so as you can see here, kan, bila you pasang battery menyebabkan current kita flow. Why does the current flow? Okay, so like we said, we have an electron flow. Okay, current flow is from positive to negative, but we know that you have electron flow from negative to the positive. So again, the electron would flow, kan? The electron would flow with drift velocity Vd, and kalau kita ada electric field like this, from positive to negative, the electron would flow to the positive terminal. Okay, so we already established this dalam kita punya earlier subtopic. Okay, but why does this electron gerak? Okay, for something to move, it must require energy. Okay, it must require energy. Who provides this energy, or what provides this energy? Actually, the one that provides this energy is actually the battery itself. Okay, but we term as the energy provided by the battery, kita panggilkan dia sebagai electromotive force. Okay, so electromotive force ni lah is defined as the energy provided by the battery or the cell to each unit charge that's flow through the external and internal resistance. Okay, so for our circuit here, for our current to flow, kan, the energy that provides the electron to flow, okay, in this case is actually the EMF. Okay, so the EMF here, EMF dalam battery kita is the one that provides our electron to flow. Okay, remember electron flow is the opposite flow of the current. Okay, but for it to be maintained, the energy must be supplied from the EMF. Okay, but then selama ni kalau kita panggil EMF tu as the energy, what is our potential selama ni? Kenapa kita guna potential dan bukan EMF? Okay, so sebenarnya apakah itu potential yang kita selama ni cakap? So the potential pula is defined as the work done in bringing the test charge from the negative to the positive terminal of the battery to external resistance only. So there's a subtle difference between this tau. Sebab saya banyak cakap waktu dalam our first subtopic, since energy is the ability to do work. So if you do work, seems like you actually have energy lah. Okay, so that's true in a sense, but in this case there's actually a subtle difference tau daripada kita punya EMF dengan kita punya potential. So EMF tadi adalah tenaga yang menyebabkan charge kita bergerak. Okay, dan tenaga ni flows through both the external and internal resistance. Okay, I'll get into internal resistance in a while, but just nak korang tahu, dalam bateri kita sendiri ada internal resistance. Okay, so electromotive force ni lah yang actually overcomes this internal resistance and also gives the energy kepada kita punya charge to flow to the external resistor and also our internal resistor. Tapi kalau kita cakap just about the potential lah, ataupun the terminal potential, yang selama ni saya cakap there's a potential difference. Potential difference ini adalah term daripada chapter pertama. Remember our first chapter kita banyak cakap tentang potential. Okay, so the terminal potential is that potential is the work done in bringing our charge from which is our electron lah, from negative terminal to positive terminal. It's the work. But when we talk about electromotive force, we're talking about energy, tenaga yang diprovidekan oleh sel tu kepada kita punya elektron so that our charge can move. Okay, persamaan of both of them are in units of volts. Okay, so EMF ke, tak kisahlah EMF ke ataupun terminal potential difference ke, both of them is in unit of V. But now what is the difference between our electromotive force and our terminal potential? Okay, itu saya pergi selepas ni. Just nak korang tahu, perbezaan dia adalah actually the factor of this tiny thing, which is what we call the internal resistance R. Okay, internal resistance R. Apakah itu internal resistance? Internal resistance ni, bila kita ada bateri lah, tak kisahlah any type of battery bateri yang ada positif negatif tu, lithium battery and so on. So the battery itself consists of chemicals, chemicals. So for it to change the chemical energy to electrical energy, it must overcome this internal resistance R. So internal resistance is that lah, where ada bawah ni. Internal resistance is defined as the resistance of the chemical inside the battery between the pole. So maksud di sini is you ada chemical. You sekarang ni nak convertkan kita punya chemical energy into electrical energy. You tak boleh convert one smoothly one go. It cannot be converted like that. For it to be converted, it must overcome a resistance. So this resistance is what we call the internal resistance. So kita punya, let's say battery, ambil gambar situ, our battery internal resistance. So ini battery besar kita. Zoom. Ini battery kita lah. Situ kan, as I remember, positive negative, battery kita. So this is our EMF and this is our internal resistance R. Bila current flow, current flow here, current tu mesti overcome the internal resistance, so that now kita punya chemical energy can be converted into our chemical boleh convert into our electrical energy. For this to happen, mesti ada potential drop. Current ni move kepada kita punya resistor kan. There's a potential drop V here. Tapi kita tak tulis sini sebagai V sebab kita dah define our terminal potential here as V. What we write here is actually I besar, the current which moves through the internal resistance as I besar R kecil. So I besar R kecil ni is what we call the potential drop. Potential drop in potential drop pula. Potential drop sebenarnya semua benda berlaku. Sorry, silap ayat. Internal drop in potential difference. That's the correct word. Internal drop in potential difference. Internal drop in potential difference. So the current must overcome this internal drop for it to convert our chemical into electrical energy. Bila dia dah convert into electrical energy, now our electrical energy ni lah yang providekan tenaga for the current to flow continuously. So as we can see here, our V is equal to epsilon. So this is the EMF we call epsilon lah. Tolak I R, which is our potential drop, internal drop. So selama ni bila kita cakap tentang our potential difference, it must be equal to our EMF tolak our internal drop I R. For kita punya potential ni yang positif, negatif ni, for it to have that potential difference, it must equal to EMF tolak dengan kita punya internal drop. Bukan tambah, it tolak sebab current kita bila pergi pada internal resistance, we know that resistance slows down current, so mesti tolak lah. But from here pun you can see the EMF pula. Now as you can see, kenapa EMF kita lagi besar daripada kita punya potential difference. So this is V kan. EMF is more bigger. Here EMF is more bigger than V sebab bila current tadi pass through the internal resistance, it uses energy lah kan. So actually EMF ni kalau kita tolakkan dia punya tak payah tolak lah. EMF ni since current takes more energy to overcome this a big hurdle here, actually the EMF here is bigger than our potential drop, because when we talk about the potential difference, itu kita cakap bila current kita dah overcome bila EMF tu tak take into account kita punya potential drop. Dia tolak terus kita punya potential drop sebab kita tak nak internal resistance when we talk about our potential difference. But the EMF itself, EMF ni contains the internal drop. Itu je perbezaan dia. So for an EMF, it contains the plus potential drop. For the potential difference, kita tak nak tengok the potential drop. Ataupun internal drop tadi lah, internal drop. So that's the difference lah. When we talk about EMF, EMF is the energy provided by the electron to gerak from negative to positive terminal. It also includes the internal drop of the internal resistance. But when we talk about potential difference, Okay, potential difference tu kita ketepikan the internal drop, which is kita punya EMF tu dah memang tolak terus dengan kita punya potential drop, internal drop tadi. Okay, so when we talk about potential difference, we already subtract the internal drop. But when we talk about EMF, we consider the internal drop. Okay, so bila kita tak ada the internal drop here, when kita delete here, kita punya V equal to kita punya EMF. So battery without internal resistance or no current flowing in the circuit, kalau tak ada current flow into the circuit, then the V itself, the potential difference, equals to the EMF here lah. Okay. So again, the internal resistance is defined as the resistance of the chemical inside the battery. For the chemical inside the battery to change into the electrical energy. So chemical energy nak convert into electrical energy so that our EMF can provide the energy is actually the internal resistance R. And bila current to flow, dia akan jadi internal drop. Okay, so here's the symbol lah. Okay, so it can be here like our example above, or it can be here. Sama je. Okay, apa yang aku nak tahu dalam battery tu, there's an internal drop, there's a internal resistance where we define it bila current flow tu ada internal drop, barulah jadi kita punya V. Okay, alright, so let's try to do a bit of question here lah. Okay, question 5 and question 6. Again, you can pause the video first before we try to do. Okay. Okay, so did you guys pause the video already? Hopefully korang dah pause the video. Okay, so as you can see here for question 5, okay, we have a 12 volt battery has an internal resistance of 1.5. So kita tulis dulu, V is equal to 12 volts, okay, internal resistance of 1.5. So that is R kecil. It's connected to a resistor R equals to 6 ohm. Okay, so sir, macam mana kita nak tahu dia adalah EMF atau dia adalah potential? Usually, kalau dia tak cakap about the EMF, okay, if it doesn't state EMF pula, sorry. Usually, bila dia cakap tentang internal resistance here, okay, ni saya silap. Okay, bila dia cakap tentang internal resistance, usually what's given there is the EMF lah usually. Okay, so bila dia tak cakap tentang internal resistance, barulah kita guna V. Okay, so usually the circuit looks like this lah. Okay, so this is our EMF, this is our internal resistance R, this is our resistance R besar. Okay, so what is the current in the circuit? So we know EMF akan equal to V plus IR. Ingat, for the EMF we consider the internal resistance. Okay, so here is IR besar plus IR kecil EMF. So the EMF here is 12 equal to IR besar plus R kecil, which equals to IR besar kita adalah 6 plus 1.5. Okay, so our I here, our current here is 1.6 amps. Okay, 1.6 amps. Now, barulah dia cakap terminal voltage. Okay, so another word, kalau dia kata terminal voltage, barulah kita tulis sebagai V besar. Okay, so kalau dia selalunya cakap kalau dia cakap sini volt, tapi dia tak cakap tentang internal resistance pun, macam contoh selama soalan ni kita buat kan, our previous question just stop tanpa internal resistance, itu adalah terminal voltage. Kalau sini dia kata a 12 volt battery, okay, the terminal voltage of a 12 volt battery, itu confirm V. Okay, so be careful lah about that to differentiate between our volt and also our EMF lah. Okay, kalau dia tak cakap about internal resistance, itu adalah terminal voltage. Okay, so for question B, confirm V equal to I, R besar. What is I? 1.6. What is R? Our R here doesn't include our internal resistance. Remember, bila kita cakap tentang terminal voltage, we don't include the internal resistance. Okay, so it's times by 6. So kita punya volt here is actually 9.6 volts. Okay, for our question. Now, what about for our question 6? Kalau tak buat, I'll give you a bit of time. Pause the video first, baru buat. Remember, you learn more by doing the question. Okay, so hopefully you tried to pause the video first. Okay, shows a battery with EMF 12 volts. So EMF 12 volts meaning that this is 12. Okay, internal resistance R sama dengan 2 and also resistance sama dengan 4. What is the reading of ammeter and voltmeter in the circuit? Similar again, you use the EMF equals to V plus I besar R. So EMF equals to IR plus IR, which is equal to IR plus R. So what is I? I is EMF divided by R plus R, which here kita akan dapat 12 per 4 plus 2. So from here should be korang patut dapat sekejap, mana tu? 12 bagi 4 plus 2. Okay, so you should get the current equals to 2 amps. Okay, 2 amps. Then what about for the volts? Voltmeter. Alhamdulillah, sorry. Okay, so for the voltmeter, you consider the terminal voltage, you don't consider the internal resistance. So I, R besar. 2 darab dengan R kita adalah 4. So it should be equal to 8 volts. Okay, 8 volts. Now for question B. When a 4 ohms is replaced by a conductor with 0 resistance. So katakan sekarang ni, I change this into just object ni, tapi tanpa resistance. Okay, what is the new reading of the ammeter and voltmeter? Okay, now you do the same thing again. Epsilon sama dengan IR plus IR, IR plus R. So EMF kita tadi berapa? EMF kita adalah 12 equal to I kita. We want to find kosong plus 2, which I here is equal to 6 amps. Now for question part 2, V sama dengan IR. Okay, 6, what is our R? R is actually 0. Remember terminal voltage, we don't consider the internal resistance. So V is equal to 0. Okay, in this case, 0 volts lah. 0 volts for question B. Okay, so just to summarize, okay, we've learned perbezaan lah tentang EMF and also tentang kita punya potential difference ataupun terminal potential. Okay, terminal potential difference or terminal potential lah. Okay, when we talk about EMF, it's actually the energy which is provided by our charge to flow. Okay, for energy provided our charge to flow lah. Okay, particularly the electron. Okay, from negative to positive. Okay, when we talk about terminal potential difference or potential difference in general selama ni kita guna, we talk that in terms of the work, the amount of work done in bringing. Okay, katakan kita bring work selama 5 joules. Okay, 5 joules per unit one charge. Okay, so the work yang untuk menggerakkan dia adalah the terminal potential, but the energy untuk benda tu bergerak is the electromotive force. Okay, and when we talk about the electromotive force, we consider the internal resistance. When we talk about the terminal potential, we do not consider the terminal potential. Okay, terminal potential ataupun the internal resistance. Sorry, the internal resistance. When we talk about the electromotive force, we consider the internal resistance. When we talk about the terminal potential, we do not consider the internal resistance. And the EMF is usually bigger than the terminal potential because now it contains the internal drop IR. Okay, whereas the volt V tu kita dah tolak sekali dengan IR, so it should be less than kita punya EMF. Okay, and we talk about the internal resistance, where internal resistance is actually the resistance when we want to change the chemical energy into the electrical energy. Okay, so lupa nak cakap, the internal resistance depend on the type of chemical lah dalam bateri kita. I'm not sure about itu kimia, right? But you have like lithium battery and so on. So the value R tu akan berubah depending on the type of chemicals you use. Okay, so I hope to see you guys for the next subtopic, which is series and parallel. Bye.